In the cosmic theater, a new drama is unfolding, not in distant galaxies, but in the quantum realm, where the rules of reality are rewritten at every turn. Here, the boundaries between the possible and the impossible blur, and the very fabric of existence becomes a canvas for human imagination. Here, human ingenuity is reaching into the fabric of reality to solve our greatest challenges. Scientists and engineers are pushing the limits of what we know, venturing into realms that were once the domain of pure theory and speculation. We stand at the dawn of an era where quantum computing and artificial intelligence are merging, creating a synergy that promises to transform every aspect of our lives. This is not just a technological leap, it's a fundamental shift in how we approach problems and seek solutions. This convergence could reshape our world, unlocking possibilities once confined to science fiction. Imagine breakthroughs in medicine, energy, and communication, all accelerated by the union of quantum mechanics and machine learning. Classical computers are like light switches, on or off, 1 or 0. Their logic is binary, and while powerful, they are ultimately limited by this simplicity. But the universe is quantum. Particles exist in multiple states at once, defying our everyday intuition. Quantum computers embrace this strangeness, operating in a realm where uncertainty is a resource, not a limitation. Quantum computers harness this, representing vast possibilities simultaneously, tackling problems that paralyze even supercomputers. They can process information in ways that were once thought impossible, opening doors to new discoveries. AI, meanwhile, learns and adapts, but is limited by classical hardware. Its potential is immense, but it's held back by the constraints of traditional computing power. Imagine giving AI a quantum brain, a partnership that could explore infinite solutions at once. This fusion could allow AI to solve problems in seconds that would take classical computers millennia, revolutionizing fields from climate modeling to drug discovery. This is the horizon before us. Quantum AI designing new medicines, discovering materials, and optimizing global systems. The impact could touch every industry, every community, and every life on Earth. The quest to build these machines is one of the greatest scientific endeavors of our time. As we stand on the threshold of this new frontier, the future is limited only by our imagination and our determination to explore the unknown. Every journey begins with a bold step. For Google, that step was into the uncharted territory of quantum computing. For Google's quantum AI lab, that was Sycamore, a quantum processor designed to push the boundaries of what we thought was possible. In 2019, Sycamore achieved quantum supremacy, solving a problem no classical computer could tackle in a reasonable time. This milestone was a significant leap forward in the field of quantum computing. Its task was to verify the randomness of numbers, a calculation so complex, a supercomputer would need 10,000 years to complete it. This was a true test of quantum capability. Sycamore did it in just over 3 minutes. This was not just a minor improvement, it was a revolutionary shift in computational power. This wasn't just an improvement, it was a fundamental shift in what's possible. The excitement in the lab was palpable as researchers realized the implications of their achievement. The demonstration was a proof of concept. Quantum computation was real. It showed that quantum computers could perform tasks that were previously thought to be impossible. Critics noted the task wasn't practical, and Sycamore was noisy and error-prone. The road ahead was still fraught with challenges. Its quantum states were fragile, easily disturbed by the environment. This fragility made it difficult to maintain stable operations. Yet, Sycamore's achievement ignited the field, transforming quantum computing from theory to a global race. Researchers around the world took notice and began to push the boundaries even further. It signaled to the world that quantum power was now grounded in fact. The era of quantum computing had officially begun. The challenge ahead was to make quantum machines more reliable and useful. This would require overcoming significant technical hurdles. Sycamore proved we could build machines that speak the universe's language. It was a testament to human ingenuity and perseverance. Now, the goal is to make them solve problems that matter. From drug discovery to climate modeling, the potential applications are vast. The symphony had begun, faint but undeniable. Each note represented a step closer to a future where quantum computing could change the world. The next movement would demand even greater breakthroughs. The journey was far from over, but the path was now illuminated. If Sycamore was the first note in the symphony of quantum computing, a bold experiment that proved quantum supremacy was possible, then the Willow chip was the orchestra coming together, each instrument finding its place, each note resonating in harmony. Sycamore showed us what was possible, but Willow showed us what was achievable. The Willow chip didn't just build on Sycamore's foundation, it reimagined what a quantum processor could be, orchestrating complexity into something beautiful and functional. The biggest obstacle on this journey? Quantum errors. Tiny, unpredictable glitches that threaten to unravel every calculation. Qubits, the heart of quantum computers, are incredibly fragile. Even the faintest vibration, a stray electromagnetic wave or a change in temperature can corrupt their delicate state, making reliable computation nearly impossible. Quantum error correction was the answer, encoding information across groups of qubits, so they could check and correct each other, like a team of watchful guardians. But early attempts at error correction were a paradox. Instead of fixing problems, they often introduced even more errors, making the system less stable. It seemed like an unsolvable puzzle, until Willow. Willow was different. It could learn from its mistakes, using advanced algorithms and real-time feedback to adapt and suppress errors as they happened, almost like it was thinking on its own. For the first time, adding more qubits didn't make things worse. It made the system more stable, more robust, and more powerful. This was the Holy Grail: scalable, fault-tolerant quantum computing. Willow's performance stunned even the most optimistic researchers. In a landmark demonstration, Willow solved a puzzle in just 5 minutes, a problem so complex it would take the world's fastest supercomputer 10 septillion years to crack. The breakthrough sent shockwaves through the tech world. Suddenly, the impossible seemed within reach. Willow is more than just a processor. It's a prototype for the quantum computers of tomorrow, a glimpse into a future where computation knows no bounds. It proved that scaling up quantum machines doesn't have to mean more chaos. With the right design, it means more power, more reliability, and more potential. The blueprint for the 21st century computer had finally arrived, promising a revolution in science, technology, and beyond. The quantum era was no longer a distant dream. It was here, and Willow was leading the way. While Google explores quantum frontiers, Tesla pursues AI mastery in the classical world. Tesla's goal cars that see, think, and navigate like humans, full self-driving. The engine behind this is Dojo, a supercomputer built to train Tesla's neural networks. Every Tesla gathers real-world data, fueling AI learning at massive scale. Dojo processes this ocean of data, accelerating AI's ability to handle complex scenarios. Tesla's approach: build AI that understands the world through vision alone, requiring immense data processing. The same principles power Optimus, Tesla's humanoid robot. Tesla's AI and data are its crown jewels, the foundation of its strategy and competitive edge. Now, a speculative crossroads. Could a future quantum AI unravel the secrets of Tesla's AI? Quantum computers excel at optimization, finding the best solution among astronomical possibilities. In theory, a powerful quantum AI could analyze outputs and infer the architecture of complex systems. Today, this remains science fiction. Current quantum computers are experimental, not omnipotent. Tesla's AI is a moving target, constantly evolving. As quantum power grows, so do the ethical questions about how we wield such technology. Imagine collaboration, not rivalry, a Google-Tesla alliance. Google's quantum AI could tackle Tesla's toughest challenges, from battery design to factory optimization. Quantum computers could simulate millions of chemical compounds, accelerating breakthroughs in energy storage. They could optimize manufacturing, finding efficiencies invisible to humans. A partnership could create a feedback loop: quantum insights, fueling real-world innovation. The vision: a quantum cluster in space, solving humanity's biggest problems. The challenges we face are too big for any one company. Together, their fusion could truly change the world. Quantum AI's true revolution will ripple across every field, especially medicine and materials. It can simulate nature at the molecular level, unlocking cures and new materials. Drug discovery could shift from trial and error to precise, personalized design. Quantum AI could test millions of drug candidates virtually, accelerating breakthroughs. The same applies to materials, designing alloys, catalysts, and superconductors from the atom up. Startups like SandboxIQ are already combining quantum and AI for biopharma and energy. The journey from algorithm to life-saving drug is long, but the path is now visible. We are moving from accidental discovery to intentional creation. The quantum age has sparked a global race, with stakes higher than the space race. Whoever builds a large-scale, fault-tolerant quantum computer will wield immense power. Tech giants and governments are investing billions. It's a marathon, not a sprint. Progress requires both hardware and software, quantum algorithms and machines. Google's open-source approach is growing the ecosystem, accelerating discovery. Startups and giants alike are pushing boundaries, creating a vibrant, competitive field. This is more than a race for dominance. It's a race to solve humanity's biggest challenges. The finish line? A safer, healthier, more sustainable world. We stand on the edge of a new era, where quantum computing and AI redefine our relationship with information. This journey demands scientific brilliance, engineering, and wisdom. Building fault-tolerant quantum computers will take years of relentless innovation. We must invent new algorithms and confront profound ethical questions. How do we ensure quantum AI benefits all? How do we guard against misuse? Like the telescope and microscope, quantum AI gives us a new lens, one to design our future. It lets us move from passive observers to active architects of reality. The adventure ahead is one of curiosity, persistence, and wonder. If we navigate wisely, the quantum age promises a profoundly better future. The cosmos is waiting.